Hello everyone, welcome to our MSc Chemistry class, and we're in book 3, chapter 6, which is entitled Heats of Reaction. So for a start, we all know that a reaction consists of reactants and product. So it's like the reactants form the what? Form the product. Now, for the reactants to form the product, it means that there has to be bond breaking, because the compounds or molecules reacting, they have their own bonds. All right, so for them to react to form new product, there should be the bonds breaking. Now, for the bonds to be broken, remember that we need energy or some force to break the what? To break the bonds. So that breaking of bonds, that energy is now in form of what? Is now in form of heat. So in chemistry, we're talking of energy. In this case, we'll be talking of heat. All right. So the heat that is used for energy bonds breaking and bond what? Bond formation, for it to move from the reactants to the product. Now remember, we always say that energy is neither created nor destroyed. It only changes from one form to another. So in this case, it's the same heat energy that changes from the reactants to the product. So in this type of in this topic of heats of reaction, we'll be talking about how heat changes, all right, from like the reactants to the product. So there are always two ways in which heat changes. So we can imagine having a beaker. In this beaker, let's have these small lines to represent reactants, so that we understand what we are talking about. All right, so suppose these are the reactants and that is our beaker. I'll assume that inside here we should put it A. That A will represent the reactants, you understand? And outside here, let's put B. Okay, and this B represents not only this side but also everywhere here, everywhere out here. Okay, it's B. So this A will be called the system. That's the short form for the system. And this B will be called the surrounding. Yeah, at least. So what is the system actually? So the system consists of the reactants of the reaction, all right? And B consists of the when you say the surrounding, it consists of the walls of the container or the walls of the beaker and the air outside. So the air is just the general term. It should be the air or anything outside the what? Outside that beaker. And mind you, if you have anything in the system, for example, we can have a steering rod, which is not part of the reactant, but is being put in the beaker. That will also be called a surrounding. I don't know if you get the point there. All right. Yes. So system is strictly to the reactants, those taking part in the reaction. But outside the reactants, that is the surrounding. Because when you hold the beaker, you'll be part of the surrounding. Okay. Yes. So in this case, heat will be moving in two ways. All right. It will be moving from A to B. That is to say, from the system to the surrounding. And scenario B is that that same heat or that same energy will be moving from B to A. Okay, so the question is, what are these called? So let's dig deep together. Come here, let me show you something. The type of reaction in relation to heat changes. So in this case, we have two types of reaction in relation to heat changes, and these are exothermic reaction and endothermic reaction. By the way, what is exothermic reaction? As the name suggests, exothermic. We have the word X here and here thermal. So remember, X means out, and thermal means heat. Thermo means heat. So when talking of heat, exothermic reaction, we're talking of the heat that is being given out. All right. Yes. So suppose you're having a beaker, as we had in the first place, and these are the reactants inside this beaker. Okay. These are the reactants. Okay. So heat in this case is being given out. So this arrowhead means the direction of heat that is being given out from the system to the surrounding. So heat is being given out. Okay, so from the previous analogy, it means that we are in situation A, whereby heat is moves from A to B, from the system to the surrounding. So how do you know that heat is moving from A to B, or from the system to the surrounding? So there are two ways. The first one is that the reaction mixture and the surrounding gets hotter. Okay, so in this case, the surrounding, when you touch the beaker with your palm, you see that you'll be feeling warm, you'll be feeling some heat. Okay, yes. So that heat shows that the energy is moving, or is being given out from the system to the surrounding. The second way is that if you have a thermometer and you mess it in here, you see that there'll be rising temperature. So that rising in temperature shows that the heat is being given out. So that's exothermic reaction. Now, what are some of the examples of exothermic reaction? Here we have some of them, and the first one is combustion. Remember, combustion is the reaction between energy and oxygen, like fuel and oxygen, to produce carbon dioxide, water, and the energy, and the heat itself. Okay, so what I'm talking about here, we can have some fuel, for example, methane, ethane, propane, those ones. Okay, because they also undergo combustion. Or else you can have petrol, diesel, and other things. Okay, those ones, when they're burned in air, they'll produce carbon dioxide, water, and energy, heat energy. And that heat energy being released is now the heat that we're talking about, exothermic reaction. Okay, in biology we have respiration reaction. It's the same combustion. Okay, we're adding a different name, whereby when you eat, the food that you eat contains chemical energy. All right, so when you breathe in air, oxygen, that oxygen burns the chemical energy, or that burns the food, which is like the fuel, to produce carbon dioxide, which you breathe out, plus some water and energy. So that heat energy is the same energy that help you to do your work, or like when you're listening to this, when you're watching this video, you're using the same energy. Okay, and when you're feeling cold, you sleep, you cover yourself with a blanket. After some time, you feel warm. Where do you think that warmth comes from? The warmth is coming from you, the energy that you release. Only that the blanket is an insulator, so it's not allowing heat to be given out. So it's you like covering yourself. So yes, that's also an exothermic reaction. So next is neutralization reaction, which is the reaction between an acid and a base, or an alkali, to form salt and water and some energy. So why is this happening? Remember, the energy is being used to break the bones. Okay, so when the bones are broken, there's that release of energy. Okay, that was stored inside those bones. All right, apart from that, we have rusting, which is the reaction between water, oxygen plus iron, to form that iron flakes, that brownish thing. So yes, and we have dehydration of sucrose by sulfuric acid, reaction between sodium hydroxide and water. So yeah, these ones produces heat, which is now the exothermic reaction. All right, next is the endothermic reaction. So endothermic reaction is now the opposite of the exothermic reaction. Remember, in exothermic, heat was given out. So in this case, it's obvious that heat now is being taken into the system from the surrounding. Yes, so here the heat is being taken from the surrounding to the system. So outside the beaker is the what? Is the system, the surrounding. So heat is being taken from the surrounding to the system. So yes, we can define an endothermic reaction as the reaction that takes in any heat energy from the surrounding. So heat is being absorbed in this case. All right, how do you know that yes, this one is endothermic reaction? The issue is the surroundings, that is the air and the walls of the beaker or the container, feels colder. So when you hold the beaker with your palm, you feel cold. Why? It's because heat is being taken from you, because you are now considered as the surrounding to the system. Okay, that's why when you hold a beaker containing the ice, okay, how do you feel? You feel cold. And then when you look inside the beaker, you see that the ice has started melting. Where does that energy for melting has been taken from? It's from you. That's funny, right? Yes, but that's exactly what happens. So what are some of the examples of endothermic reaction? We'll be talking of photosynthesis. So photosynthesis, remember, is a reaction between the oxygen and carbon dioxide in the presence of light and chlorophyll to form glucose and oxygen. So yes, I've heard many people after maybe they have ate, okay, they'll be like, it's hot here, let's sit under the tree. Okay, why is it that under the tree feels cold? Why? It's because heat or heat energy is being taken outside, like from the surrounding. So it's like outside the tree into the system, which is now inside the tree. Now because heat is being taken out, taken away from the surrounding, it means you will be feeling cold. The same example of the melting of ice. You understand now? Yes. So the melting of ice, yes, is the second example. You see, that is exactly what I was trying to say. And then evaporation of liquid water, dissolution of salts in water, for example, ammonium nitrate. When it reacts with water, heat is being taken from the surrounding. So heat is being absorbed as endothermic reaction. Yes. So any question, if you have, please write them in the comment section. I will respond to them. All right. Yeah. But then thank you for being there, taking part in this lesson. See you next class. God bless. Bye bye.